Hello everyone. Today we will just start the data interpretation portion of GRE Quant, and this will be a bit introductory lecture about data interpretation. And in the next lecture, we will just practice for data interpretation. So let's get started. What exactly is a data interpretation? Data interpretation refers to any question that involves visual information such as graphs, tables, charts, and plots. This question asks you to interpret or analyze the given data. We are given a graph, table, chart, or plot in front of us in a form of data set, and there are three questions for each data set. And three questions of data interpretation in each quant section. So basically, there are four scored sections, in which two are scored quant section and two scored verbal section, and there is one unscored or experimental section. So because there are three questions in each of quant sections for the data interpretation, that's why if I consider two scored sections of GRE Quant, so there will be 6 data interpretation questions overall. And as there are 40 questions, so if I just consider percentage of data interpretation, that will be something around 15%. Okay, so these questions basically test the knowledge of arithmetic concepts such as percentages, ratios, and fractions, and the basic statistical measure that include mean, median, mode, and many more. The basic concept exactly same which we discussed so far about arithmetic and the statistic portion, but the only thing is you are tested by those concepts in a graphical form. And for example, you're asked to find the percentage increase, percentage decrease, what is a maximum percentage increase, what is a maximum percentage decrease, what is the median of the graph. Okay, so before getting into the strategies of how to solve data interpretation, first let's see what are the possible kind of graphs which you could see in the actual exam. So type of data interpretation graph. So first one is pie chart. So what exactly is a pie chart? Pie chart is a circular statistical graph which is divided into slices in order to illustrate the numerical proportion. For example, and for this I just took the graph from the ETS guide and the old GRE big book. So this is an example of pie chart in which we are given United States production of photographic equipment and supplies in 1971. And in total, there are $3,980 million. And overall, this is 100%. And this is further divided into 6 slices based on the numerical proportions. And this could be in form of percentage, and this could be in form of actual numbers. And just like in this scenario, we are given the total amount and the percentage, which is divided into 6 parts. 47% for sensitized goods, 5% for motion picture equipment, up to so on. And if you add all of these, this will add up to 100. So this is a very basic type of question in which you are given one pie chart. There could be a scenario in which you are given 2 pie charts at the same time, and you need to use both of them. Just like in this one shows, this is the income and expenditure of an international service agency for year X. And there are 2 pie charts. One shows the income and one shows the expenditure. And total for both are given. There could be another scenario in which, just like if you see the income and we are given the United States government is around 26.6%, there could be a scenario that this United States government is only this 26.6% is further divided into another pie chart, right? So this is just idea about the pie chart, how the form of graph you could see in actual exam. And in such pie chart questions, the most common type of question involve the percentage increase, percentage decrease. And there's one more type of question which is pretty much common. That is, we know that the overall angle of a sector in a circle is 360 degrees. The question could ask that if I consider this sector of United States government, which is 26.6%, and what will be the angle in degree for this United States government, right? So this is just a bit idea about the pie chart. Okay, so now let's move further. Next one is about the line chart at the time plot. So what exactly is a line chart? A line chart uses points connected by line segment from left to right to demonstrate the change in values. And if the horizontal axis is exclusive time based, that will become time plot. So I just took another example from the official guide. So this shows the fall enrollment for college A from year 2001 to year 2009. And on the x-axis are the horizontal axis. We have years from 2001, 2002 to up to 2009. And on the vertical axis, we have enrollment from 0 to 5,000. And each of these dots represent a coordinate. For example, for 2001, this is something around a bit closer to 1,000, maybe 1,200. And just like in 2003, this is 2,000. So this could be in a single graph as well as a multiple graph as well. Just like in this student population and total school expenditure in the United States from 1970 to 1980. And first one shows the student population and second one shows the total school expenditure. And further, when we see the strategies for solving the data interpretation, you will see that in the actual exam, most of the time you will see combined graphs that incorporate pie chart as well, histogram as well, line chart as well. So in those, you need to use all of these, right? Okay. So next one is bar chart. So what is it is a bar chart? Bar chart is a graph which with rectangular bars usually compare different categories, and these could be vertical as well as horizontal. So this is further divided into horizontal and vertical. So first of all, just seeing the vertical one, these are the vertical rectangular bars, and these are the 5 categories which you are showing: college A, college B, college C, college D, and college E. And each of these represent the enrollment of each of these colleges. And if I see the horizontal one, so again, this is the same thing, but represented in the horizontal manner. And just like number of physicians within medical and surgical categories in 1,000. And this include medical as well as the surgical, right? Okay, so this incorporate only one bar for the horizontal and vertical. And this throughout represents same category. There could be a scenario that this same category is further divided into subcategories. And that one is usually known as the segmented or stacked bar graphs. For example, and definitely there could be vertical as well as horizontal as well. So if I see the vertical one, so again, we have 5 categories of colleges, and each category is further divided into full-time and part-time. Just like if I see the college A, total enrollments are 4,000, but in that enrollment, part-time there are 1,000 students and full-time there are 3,000 students. So in this way, each of these bar further represent further divided into subcategories for each of these 5 categories. And likewise for the horizontal, this is the population in million, and we have these 7 countries, and each of the population for each of the categories further divided into 3 portions. And we are given the range from 0 to 14, this is blue, from 15 to 64, this is orange, and from 65 to above, this is gray. And the another type of bar chart, which is side-by-side bar chart, and again, that will be vertical as well as horizontal. And if I see the vertical one, again, I'm having 5 categories, but for each, in this category is year. For each year, there are 4 bar charts. And this could be known as bar charts or bar graphs. These are one and same thing. Just like in 1968, we have 4 categories further. One includes the NATO countries, second one is Warsaw Pact countries, third one is United States, and last one is others. And same for the horizontal as well. And next one is histogram. So someone might argue that as we discussed in the last class, when we're discussing the histogram, that histogram is a bit similar to the bar charts, but with a minor difference. The difference is that in the histogram, we usually consider the continuous data, but in the bar charts, we consider discrete data. And we consider the numerical data in histogram, while in the bar charts, we consider categorical data. And again, this could be vertical and horizontal as well, but most of the time you will see in exam, this is the vertical one. And just like this, we are given the number of children with the relative frequency. Okay. Now the next type of chart is about the scatter plot and best fit lines. So what is it? Is a scatter plot. Scatter plot uses dots to represent values for two different numeric variables so that it shows the generic relationship between two variables. And for example, if I say this, each dot represent two variables. One is the training index, another one is the time. And if you see this closely, this is showing a declining relationship. And to best show the relationship, there is usually a straight line, a best fit line is drawn. And this is not that much common in exam. Okay. This is again a very rare type of data interpretation graph, which you will see in the exam, which is a Gantt chart. A Gantt chart is commonly used in the project management. And what is it? Is a role of the Gantt chart? It is actually basically it is a useful way of showing activities displayed against the time. And if we see this, just like we have all of these are the activities, wrestling, typing, badminton, and whatever are those. These are activities, and each of these horizontal bars represent the range, the minimum value and the maximum value. And on the horizontal axis, this could be time, just like in this, we have number of calories burned per hour. If I see the wrestling, the minimum value for this, that will be around 350 calories burned per hour. And the maximum value is something around greater than 550, for example, 560, right? And this is another type of question, but this is a very rare type of question. We will discuss this question when we move to the practice session. And Box-and-Whisker chart, which we discussed in the last class. And this is again a 5-point summary, which shows the minimum value, maximum value, low quartile, upper quartile, and the median. And in the form of graph, this shows something like this. This is the weekly report monthly temperature, and these are the 12 months with the temperature. And for each of the month, it shows the minimum temperature, maximum temperature. This middle line shows the median. This is lower quartile, and this is upper quartile. And this is the last type of the graph, not graph, a chart which you see in the data interpretation. And this is another very common type of data interpretation graph or chart, and in which you are not given a graph, but a chart of numerical values, just like in this last week total hours worked and hourly wage for the cashier at market X. And these are the cashiers, these are their hourly wage, and these are total hours worked. But remember one thing, whenever you see such questions, always read the note. The note bears a lot of importance. In the chart, you won't be provided with all of the detail, but if you miss the note, you will hopefully make the mistake in the question. And again, this is one chart, and this could be the combination of multiple charts as well. Just like first one shows the average cost to operate 3 types of cars over the 4 years, and second one is the average annual saving throughout the carpooling to work rather than driving alone. So these are the common type of the data interpretation graphs which you will see in the exam. But most of the time you will see the multiple of the combination of these charts. for example, you could see the bar charts, pie chart, and the line graph at the same time. You could see this chart of numerical values, bar charts, pie chart at the same time, right? Okay. Now let's move to the general strategies for solving the data interpretation. There are some strategies based on the graph, just like for the bar chart, for the pie chart, for the line graph, which we'll discuss while solving the questions. But there are general strategies which we could use to have a better idea about each of these question data interpretation part. Okay, so first start with this one, that understand the bigger picture. What that means? When you will see the data interpretation question, just take 10 and 15 seconds to get overall idea about the whole of the graph. How can you do that? Just, yeah, very important thing. Read any accompanying text. Just like in the last question, this note bear a lot of importance. And if you miss such note, you will most hopefully make a mistake, right? And yeah, units are very important. Just like in most of the cases, in the it is prepped this way that actual graph has unit, for example, per kilometer, but the question is asked in a unit of per miles, right? So if you miss the unit of measurements and if you miscalculate, the question will definitely be wrong, right? And the next thing is, what can we get idea from the graph with axis? That whenever you see the data interpretation question with axis, let me show you, just like this. Always see whether the starting point is 0 or not. Just like in this, if this is 0, this is 10, this is 20, this is 30, and this is 10, this is 20, and this is 30. So you can see that both of these start with a 0. But in some scenario, it is trapped this way that they don't start with 0. They start with, for example, this is 30, and this shows something like this. And that's mean this is not started from 0. This is 40, this is 50, and this is 40. And one more thing is, see whether the gap is constant or not. For example, there's a gap of 10 in this, gap of 10 in this, gap of 10. But there could be a scenario that this is not a constant. For example, this is 10, this is 40, this is 100, this is 20, this is 50, this is 90, right? So whenever you see such questions and involving the axis, the x-axis and the y-axis, first of all, see whether what is the starting point, whether it's starting from a 0 or not starting from a 0. See whether the difference between the values on the axis is constant or not, right? Okay. So the whole of this will just give a bigger picture about the data interpretation, about each of the graph which is asked in the exam. And next very important thing, just like we discussed earlier, that the units difference. The question, just like I tell you earlier, that the question could ask you in the units of miles, but the graph or data set is in the form of having units in kilometer. So just in most of the time you will see the difference, unless until you are perform worse and you get an easy section, then things will be straightforward. But in the median or hard section, most of the time, if you see this, there is a difference of unit in both of these, and you need to figure that out, right? And one more thing, check the answer. This is a very important thing. And I will say this is the most important strategy which you should use. While dealing with the data interpretation, check the options before solving. What that means? And whenever you see the question, okay, you just see the question. Now see the options, whether the options are close apart or one thing is that just like option like this, for example, 11, 12, 13, 14, and 15. The other way is the options are like, for example, 10, 50, 150, 200, 500. So if the options are very much close, then it is not a wise idea or good idea to approximate the values. But if just like the options are very much apart, it is better to approximate instead of using the exact value. In most of the time, data interpretation, you have to approximate the value. Approximation, and that is only possible and best possible when the options are wildly apart. But if options are very much close, it is not wise idea to approximate. This is first thing. The second thing is that just see the options. What is the accuracy of the option? For example, if I deal with the probability question, I'm asked about the probability of anything. And if I see the options are, for example, just like 0.2, 0.3, 0.4, 0.5. So these are in decimal form, right? The possible options could be in the integer form, in the fraction form, in the decimal form. And for example, if these are 1/2, 1/3, 1/4, and 1/5, and you're asked to find the probability, see the options. And for example, if the options are in the fraction form, then you don't need to convert those in the decimal, because first you will convert into fraction, then you will convert into decimal. Instead, first see the options, see what is the required accuracy for each of these options, whether that is in the form of integer, fraction, or decimal, right? This is second tip. And first one is approximation. Okay, we'll discuss this. Yeah. And another important thing for the graphs involving percentages. I told you about the rule of 1 and 10 when we were discussing the percentages. That is, whenever you see some value, numerical value, for example, if I given that we have a graph and that shows some revenue, and total revenue is something $250, for example, in millions. And they could be pie chart or something like that. Whenever you see, quickly convert this into 1% and into 10%. So what is 1% of this? Just divide this by 100. That will be $2.5 million. And what is the 10%? Just divide this by 10. That is $25 million. Now, you can form any of the percentage based off these two. You could easily form 5%, just multiply this with 5. You can easily form 25%, 30%, 50%, 80%. You can form anything. Instead of using a calculator, you can do quickly by this way. So whenever you see such question involving the percentages, quickly convert that into 1% and 10% and just use those values. And try to avoid the use of calculator as much as you can, because it is so much difficult to use a calculator, and it is very much slow. So if you start using the calculator, that will literally waste your time, right? Okay, so another thing is, there was a data interpretation graph involving two pie charts. And the question was something like, but for example, this is A, this is B, this A is some percentage of that B, and we don't know the exact value. What is the value of this and what is the value of this? So in that scenario, just see the percentages and try to come up with some value, so that if you take both of these percentages, the value is an integer, right? So try to assume a good number when you are not given the actual value for the question like these. And try to have a minimum use of calculator. And another very important thing, that do not confuse rates or percent with the number. For example, just take one basic example to get an idea about this. For example, there one is X and one is Y. And this is a cost in 2000. This is a cost in 2010. And this is a percentage change, a percentage increase. And this is a dollar change. So for example, cost in 2000 is $10 and this is $20, and cost in 2010 is $12 and this is $24. So if I see the percentage change, a percentage increase in this, that is same in both. This is 12 minus 10, 2 divided by 10, percentage increase, that is how much? That is 20%, and percentage increase in this as well is 20%. But the dollar change in both are different. In first, this is 2, and in this is 4. So the takeaway is the greatest increase in percentage doesn't mean the greatest increase in dollar. And just like in this, the same increase in percentage doesn't mean the same increase in dollar, right? So never confuse percentage change with the actual value change. Okay, now we will just solve one data interpretation questions and try to implement the strategies what we have discussed so far. I just took one question from the paper-based GRE exam, and let's try to see. Okay. We are given one bar chart and one pie chart. And in the first bar chart, that is a gasoline tax revenue. Okay, so that's the tax revenue as a percent of total retail gasoline sale in 2000. So to get a general idea, first of all, just read these statements for each of the graph so that you know what is written in the graph. And from the shape, I can see that this is a percentage, and what percentage, that is a tax revenue in the numerator, and in denominator, I have total retail gasoline sale for 2000. And these are the countries. And in the second pie chart, that is a distribution of Germany. And this is this thing. This Germany is distributed, and total tax revenue for this is divided into 5 slices: income tax, gasoline tax, tobacco tax, others, and corporate and trade taxes. We don't know the actual value, so we can't use the rule of 1 and 10 in this. Okay, so let's move further. And one more thing, you don't need to understand whole of the graph at first, because most of the things are irrelevant to us, and we get the basic idea. Now let's move to the questions and see what is only relevant part. So if we move further now, let's see the first question. That is, what is the median of the percentage values? These are percentage values representing gasoline tax revenue as a percent of total retail gasoline for the 9 countries listed. So these are 9 countries which are listed, and the question asks for the median. So what is a median? Median is the middle value when data is arranged in an order. So based on this, we can quickly visualize this. So this is the lowest one. This is the next one. First of all, total values are 9. What is a median? Median will be just add 1 in this and divide by 2, and that will be 5th value, and that value will be the median. So see, this is the first one, this is the second one, this is the third one, this is the fourth one, and this is the 5th one. And above that, all of these are greater than this. So our required value is this 67.6%. So based on visualization, we have quickly solved this, that what is the median of this first graph, right? Okay, so one more thing, carefully read the question asks for the median of which graph, right? Just like question clearly mentioned that gasoline tax revenue as a percent of total retail gasoline sales for these 5. Okay, this was relatively easy question. and the answer is A. Now let's discuss this one. And in this, the question states that in 2000, the amount of Germany gasoline tax revenue was approximately what percent less than the amount of its income tax revenue. So one is income tax revenue and one is the gasoline tax revenue. So the question asks that this gasoline tax revenue is how much percent less than income tax revenue. One way is that this is a Germany 70.7%. Just assume some value and use that value in this and find the percentage. If we think closely and logically, all of these are percentages of same value. So when we use the percentage increase or decrease formula, the actual value will cancel out. So there is no need of that value. And see the options, 10, 20, 30, 40, and 50 options are wide apart. So quickly approximate. This is 28.6. I can write this as around 30%. This is 20.4%. I can also write this as 20%. So now if I want to find this is how much less than this. So how can I do this? So what is a percent change? Bigger minus smaller. And one more thing, in this question, there is sometimes confusion that what value will be in denominator. The question says percent less than. Whatever the thing is after the than, that will be the denominator. So amount of income tax revenue. So what is that? That is 30%. And you to find a percentage change. So that will be 100. That this is 10 divided by 30 into 100, which is around 33.3%. And if you see the options, which are the following closest? That is option C. And if this option value is greater than 35%, then you will move to the option D. But this is less than 35%, and this is a bit closer to the option C. That's why the option C is the answer, right? So see the takeaways. Just see the options. See options are wide apart. That's mean you can approximate. Now just see the percentage is 28.6. Make this 30% to get a good whole number value, and make this 20%. You need to find this is how much less than that. So in the numerator will have a change, and denominator we will have a bigger value, that is 30. So just multiply with 100 and you will get this 33.3%. That's why the answer is option C. Okay. Now let's move further. That's why the answer C. This is a bit tricky question. So if you read this question, the question states if the Germany total tax revenue in 2000, and we know this actual value is how much? $170. Approximately what was the amount of total retail gasoline sales? And if you see this, these are taxes. If you want to convert this into the sales, we need to use both of the graphs. So if total is 170 and the gasoline tax is, and again now see, first of all, see the options. Options are wide apart, so it is good idea to approximate. The gasoline tax is how much? 20.4. So I can approximate this as 20%. So what is 20% of 170? Again, if you just use the rule of 1 and 10, so what is 10% of this? Divide by 10. So 10 is 17, 20% will be double of that. That will be 2 into 17, which is 34. Now, the gasoline tax actual value is $34, but we need to actually find the total retail gasoline sales. So we know for Germany, you know that gasoline tax revenue divided by total retail gasoline sale. into 100 is equal to how much? 72.7%. And if we use this gasoline tax, then we can find the total retail gasoline sales. Then if I use that point, so what is this value? This value is 34. And we need to find this thing. Let's keep this as X into 100 is equal to how much percent? 70.7%. We can write this as 0.7. So what will be this value? That will be 34 over 70% is 0.7 into 100. So just do this way, that instead of using the calculator, we have 34 divided by 70%. So what exactly is 70? That is 0.7. That's mean if I write this further, this will be 7 by 10. So 10 will move further upward. This is 340 by 7. Now if you see this, what is the close multiple of 7? That is 35. If this is 35, that will be 350, which is 50. So our required answer is a bit less than 50. And that is option E, right? So approximation is the key in most of the questions of data interpretation. You can use calculator for this, but that will literally waste your time. And for the and you won't get time if you want to move to some old question, if you have marked some questions. So always try to approximate. And there is one last question relevant to this. This is option E. Okay. And that is multiple choice option question. The question is based on the information given, which are the following must be true. So first thing is must be true. Okay. Now see the first one. In 2000, France gasoline tax revenue as a percent of its total tax revenue. But question we are given tax revenue as a percent of total retail gasoline sales. That's why we can't tell anything about this. It is not possible. Now let's see the next one. In 2000, the price per gallon of gasoline, but again, we don't know about the price per gallon. We are just given the taxes and the retail. We don't know about the price per gallon. That's why again, this is not possible. Now, if we see the option C, in 2000, Germany gasoline tax revenue, this thing was more than 3 times its tobacco tax revenue, which is 5.6. Yes, this is very much sure that 20.4 is greater than 3 times of 5.6. So that's why the only must option is option C, right? So in front of you, I solved these interpretation without using the calculator, and you can solve this by same method as well.